Hi all. We're going to do an introduction to the Python programming language today. My personal preference in the way I do my Python coding and also how I tend to introduce this to people who are just starting out with the Python programming language is to use a setting called the Anaconda distribution. Historically, decades ago, computers were less powerful. The internet was less connected, and Python historically was sent out in a way that was very minimal, and that way you could send out the compile and program. But the issue was that as researchers and programmers got more skilled and tasks became more complicated, you needed more functions. So the mentality is to have separate what are called libraries on the side that have these functions that you may need. For example, we'll see functions today about calculating statistics such as mean and median. We'll see functions today for making graphs such as bar graphs and scatter plots. Now, installing these extra packages in Python, in my opinion, has a bit of a steep learning curve. And therefore, I recommend that people start with the Anaconda distribution because you download everything all at once. For those who have already downloaded it, you notice there was about 500 megabytes, pretty sizable. And this way, at the moment, we do not have to worry about in installing all these extra tools that we may need because now they're already on the computer. All right, continuing forward, assuming that a person has the Anaconda distribution on their computer, what I tend to do to start the computer programs, I go to my search bar in Windows or Finder in Mac OS X, and I search for Anaconda. This is going to open up the so-called Anaconda Navigator. Long story short, the Anaconda distribution brings together many tools that may be useful to a data scientist, a computer programmer, a developer, or what have you. These days, it is recommended for most, I shouldn't say most, for people who are starting out with Python to use Jupyter Lab. This second box here. We're going to be using Jupyter Lab. For those who are curious, there are a lot of industry folks still like to use command line programming, and that's out there. And heck, you could even program in Python inside RStudio, and people are making that capability as well. But anyways, I'm going to quick launch on Jupyter Lab. And what that is going to do is actually going to open this inside my browser, inside Firefox. Now, of importance, I have, oh, by the way, during this whole entire section, when you are coding in Python, do not close the navigator. Do not close the interpreter that's doing the hard work in the background. I'm just going to minimize navigator for this section. Of importance, I'm going to be, like the R workshops I gave earlier this week, I'm going to be using the Penguins CSV data again. I went through the file folders and made sure that my Jupyter Lab is pointed in the same place as the data file, the CSV data file. that is on my computer. I'm located here, and I'm going to be doing like placing the code file in the same place on the computer as the data file. Otherwise, you would have to worry about things such as absolute and relative file paths. And finally, we could get the main show started by clicking on the big button that says Python3 Notebook. This first big button here that says Python3. These This gray area is where we're going to type in Python code. In a bit. What I'm going to do at the moment is on the left-hand side in the file navigator, I'm going to right-click on the file name and go to rename. And give that file a descriptive name. Here, I'm calling it Introduction to Python. And as always, if you have questions, feel free to ask questions in the Zoom chat. Mostly for the slideshow aspect of things, I'm going to actually click in this first code block. I'm going to go to this pull down menu here and change this to a Markdown style. So in here, I could type normally or with Markdown. And I like to, at least in the classes that I teach, uh, have some information at the start of the session to give people a sense of where we're headed. So there are various buttons you could use to run the code, such as this green, or not green, this triangle button here, which now that this is what it looks like in the Markdown code. And then when I press the triangle button, the result here. As I was babbling at the beginning, Python was very minimal. And one of the helper libraries that a graduate student created a few years ago is called Pandas. So we're going to import Pandas. And what this is someone was working in Python and they wanted tools that were actually very similar to what folks in R had. So they created Pandas for that purpose. Since you all are pretty advanced folks, I'm going to also mention the keyboard shortcuts. For example, to create a new code block, you actually what you do is from the code block, you press escape to get out of the code block, then you press lowercase b to create a new code block view. And to run a code block, when your cursor is inside a code block, you can press Shift and Enter, and it'll run the code block. Here in Jupyter Lab, if everything ran correctly, one, no error messages would appear. But moreover, you'll see a number to the left of the colon on the left side of the code. So the technical note of what we're doing next is we're going to load the data using the read CSV function in the Pandas library. So the question in Zoom chat is, sometimes I'm typing normally, sometimes I'm typing in Python code. And when you're in each code block, you could go to this pull down menu to change the input style or input language. So for example, right now in this first and third block, I have them in the Markdown style to make it a little easier to type. Whereas now in this fourth code block, I have the language set to code because I'm going to type Python code. I'm going to send the data file penguins.csv through the Zoom chat for the folks who are following along that way. And remember to put this penguins.csv file in the same spot where your code is on your computer.
Is that the same penguin as the RLab?
Yes, it is. It's the same file.
Okay, awesome.
And then once again, once I press Shift Enter to run the code block, if there are no errors or whatnot, then a number would appear on the left. Let me see if I could zoom in a bit here. So this line of code is described by the sentence above. We are loading the data. This is the file name with this read CSV function from the Pandas library. You'll notice in the computer programming mentality that what we type might have been in the opposite order what we say out loud. We ask the Pandas library to let us use the read CSV function, and then tell the computer which file we. We'll look at the data in just a bit, but I want to point out some more technical notes here. What I've been saying about code running correctly or incorrectly, let me pretend that um, nothing else was changed above, but say you Googled how to load data into Python, and you were told that this is the code, pd.readcsv. Now, when you run the code, you get or at least I get an error. One of the reasons why I say that Python has a steeper learning curve, or it's tougher to learn than R, is because the error messages might be a little harder to read sometimes. Because as code gets complicated, Python likes to tell you every place where the compiler broke down along the way, just in case it's useful to the programmer. But for now, we could look at the very bottom and get a sense that the error was in PD. The Jupyter is telling us that PD was not defined. So it's getting hung up there. Moreover, what happens what's the let me some good questions in chat. From in this file navigator on the left-hand side, for most of you, what you'll probably want to do is click on the downloads folder and just leave this here in downloads in the same spot as your penguins.csv data file. And then when you click save, then your code will be in the same spot as the data file. All right, so now back to the code itself. There are after years and years of Python programmers, they created what are called like stylistic choices, how most people do certain bits of code that are used over and over again. And one of the choices that they made was they don't necessarily want to type the word pandas over and over again. So there's this notion called aliasing. So first of all, we're importing libraries of helpful code. And aliasing says, instead of typing the word pandas later, I'm just going to type PD instead. Now, because I changed a little bit of what happened here, import pandas as PD, I'm going to run that code block first. I happen to have a number 4 by everything. And now I'm going to run this code down here that I had to load the data. And now that this PD lines up with how we defined it above, now this code is working properly. In fact, what we're going to be looking at today are these 4 packages: Matplotlib, NumPy, Pandas, and SQL. Matplotlib is when Python programmers actually wanted to make graphs like the MATLAB programmers did, that Python itself did not originally come with graph making capabilities, or at least pretty not good capabilities, not useful ones. In fact, and just a quick story about Python, and when I keep saying Python was minimal, it only came with the functions that the most pure computer programmers needed. Up until about 3 years ago, Python did not even include division. Did not include division, as in addition, subtraction, multiplication, division. Division was not even in Python by default for various numerical analysis reasons. So what we needed and still need is this NumPy package, where when people doing more advanced calculations, such as taking an integral, then folks made NumPy for them. Pandas, again, was useful for loading and working with data frames. And then finally, these days, I like to use Seaborn to make graphs because for a relatively small amount of code, you can make pretty good looking graphs. Good. Let me put that all into the Zoom window there. One of my pet peeves, and as a person who tends to grade people with computer code, is that sometimes students end up printing out the whole entire data set, and then all of a sudden you have like a 20-page document of just data, but that's even before the calculations. Fortunately, the folks over at, at Python, in particular, this is a pandas data frame. When you do something like print the data frame just to see what's in there, it's not going to print all 344 rows. As you can see with the ellipses, it's going to skip a lot of them. So it'll print the rows at the beginning and end of the data frame just to give you a sense of what's going on. There are other ways that you could get a quick glimpse of the information about your data frame. For example, if you only needed to know the number of rows and columns, we could print the data frame again, but then we type dot shape here. And that will tell us that we have 344 rows and 8 columns. For those people who are aware of object-oriented programming, the Pandas data frame that I call DF is an object, and shape is an attribute of the object. Therefore, I could type dot shape to extract that information. And then finally, one more bit of information in this realm. I like to have a list of the column names at my disposal so that later on I could quickly look them up. I could copy and paste the variable names later to avoid typos. Are there any questions from you all in the audience so far? Okay, so next what we're going to do is some sample statistics, mean, median, standard deviation. I will wax poetic, talk a lot about the dot notation. It's something that comes up, especially because I keep messing this up myself. In Python, most programmers use the single quotation marks. I myself, just because I'm old-fashioned, tend to use double quotation marks for historical reasons. In Python, it doesn't matter which one you use for most situations. In my computer programming experience, I've only run into one programming language where the quotation marks mattered in this way, and that was PostgreSQL. But But for now, if you see me accidentally switching between the two, it doesn't matter. It's my so back in pre-calculus or other math classes, when we said function composition, you might remember the phrases such as f of g of h of x, stuff like that. So up for a while, the way to compute a mean in Python was you had to load the NumPy package, you had to call the mean function. Here, because we have a data frame of several columns, we're going to use df for the data frame name. And I'm going to talk about the build lengths, which I have listed above as one of the column names. Notice for Pythonic reasons, after df, we have the square brackets and the quotation marks. For the mean is a function. So the function has the curved parentheses. And with that all said, we could get the computation out of it. However, as code gets more complicated for anyone, beginner, novice, developers, having a bunch of code like this that kind of goes inside out, that has a lot of parentheses and brackets and whatnot, it's very prone to errors. It leads to a lot of headaches later. So one of the main reasons why Python is a very popular programming language is because of this dot notation. For one thing, it could be read left to right. I'm going to take the def data frame, refer to its build length column with a dot in between, and then after another dot, call the mean function, and it'll do the same thing. But as we continue programming, this way of programming might make more sense to most people, and it's easier to type and it's easier to debug as well. And we could, as I mentioned before, compute the median and standard deviation. Now, you'll notice here I have 3 lines of code. By default, Jupyter will only output or show you the last output. So you could either make multiple code blocks like I've done before to display each output separately, or you could wrap each one of these in a print command so that all the numbers appear. In context, talking about the penguins, the average build length was about 44 millimeters. The median build length was also about 44 millimeters, and the standard deviation was about 5.5 millimeters. Next, what I thought would be useful for us to do is look at some counts. Literally going through the data and counting how many of each type of penguin there is. Fortunately, now that you have a sense of the dot notation, you could guess that from the data frame, the function for count is count. And at the moment, I didn't do anything really special. I just said apply the count function to the data frame, and it'll say in this particular setting how many observations there were in the species column, the island column, the build length, etc. You may notice that some of the numbers are not the same, and that's a hint that there was some missing data. Where this programming, where our programming skills become more powerful is when we use functions like group by. And then apply the count function afterwards. So to be honest, I probably could have found a way to make this appear a little better, but for now, at least on the far left-hand side, we could see that we have 152 Adelie penguins, 68 pinstrap penguins, and 124 Gentoo penguins. The technical note about this last output here, this table that I'm showing you right now, is that on the far left side, notice where the word species is. On the far left side, this species became the index of the table. So that, say, this row is now all talking about Adelie penguins. This second row is all talking about pinstrap penguins. And then you could also group by more than one variable. Say, in this particular data set, there were 3 species, 3 islands near Antarctica. And you could count out how many species were on each island. How many of each species were on each island. We get results like that. So for the Adelie penguins, they were split across the Biscoe, Dream, and Torgerson Islands. The chinstrap penguins happen to be endemic to the Dream Island, and the Gentoo penguins happen to be endemic to the Biscoe Island. So from here, we could ask questions like, what is the average build length of each species of penguin? And just for a quick example, for each species of penguin on each island. What I'm doing is essentially combining the bits of code that I've shown you in the past few minutes. So we're going to take the data frame, group by species. We could compute a mean. Whoops, I forgot the building. We could compute, then go into the buildings column and then compute the mean. Similarly, if your research lead asks you to group by both species and island, we have that array, the square brackets, and we could specify that a little further. Continuing with this dot notation, the data frame group by, look at the certain column, take the mean. If we wanted to sort the values, all we have to do is then tack on sort values to the chain, the chain of thought. So at the moment now, the numbers are going from lowest or from smallest to largest. And I believe if we change the ascending, you could go from largest to smallest. One place where Python gets very anal retentive and finicky is when you type the words true or false, the first letter is capitalized, the rest are lowercase. Whereas if you're working with a programming language like R, and you type the words true or false, it's in all capital letters. It's one of those things that when you're programming, you have memorized. You could also just use the letters T or F as well. One question that comes up is, well, then if after you do a bunch of calculations, how do you, is there a way that you could make, say, like a Excel spreadsheet or a CSV file that you could send to your colleagues? So I'm going to take this previous line of code, for example. I'm going to save it into a variable called results. And instead of reading a CSV file, the function is called toCSV. And what happened there was that now I have this result CSV file back on my computer. Or in other words, if I load up this where I have everything here in Windows, the result CSV file is there. And admittedly, it's kind of bare bones at the moment. All right. I might have talked pretty quickly over the last few examples. So this last bit of code to restate was what I did was I took this result from the calculations and stored it on my computer as results.csv. Are there other questions about some of the recent steps? Okay, I think what we'll do for the remaining bit of time is data visualization, graphs. And I like using the Seaborn library because, again, with a relatively small amount of code, you can make professional looking graphs. Let's see. All right, so the mentality here in Seaborn is that earlier I had imported Seaborn as SNS. We start the chain of thought with SNS, and from there, if we want to make a bar plot, for example, this is a bar plot of a categorical variable as opposed to a numerical variable. Inside the bar plot command, we tell Jupyter what we want on the x-axis and what we want on the y-axis. But we also have to tell Jupyter, the computer, where the data is coming from, because otherwise it's not obvious to the computer. And that will create our bar plot. Question in the Zoom chat was, what's SNS? Seaborn itself overall is the coding library that makes these graphs. Technically, it's a MATLAB graph, but by default, Seaborn also added these colors, also made things pretty readable already. For people learning Python, this alias SNS might sound strange, and this is kind of an old joke or reference in the Python community. About 17 years ago, I think, there was a TV show called The West Wing, and one of the characters' names was Sam Seaborn. So the folks who were making the Seaborn packages like that coincidence, and they named or they popularized this alias after the character's name, which was Sam Norman Seaborn. So when Python programmers use this chunk of code, it's just an homage to a TV show of the past. You may have also noticed at the bottom of the graph that the species names were listed alphabetically, which is convenient in most situations. However, sometimes people want to use their graphs to tell a story, and maybe you you want like the bars in different orders or whatnot. Oh, I'm sorry, I got my wording backwards. At the moment, the the names at the bottom of the graph are not. So I'm going to create a updated data frame called sorted species. Where I'm going to sort the values on the species. Then actually, let me do this. So the mentality when making graphs is that first we state what variables we want. Second, we customize the graph. for example, if we want to add a title. And then third, we actually plot the graph. This time around, I'm going to use my data from the sorted species. I have the results saved into a variable called AX for now. Just an old habit for X for axis. We use the set command to be able to make a title, etc. And then finally, we need to, at this point, because the code was a bit more complicated, we may need to tell Jupyter to actually show the graph. What did I do here? Add an extra parenthesis. Nope. So now the names of the species at the bottom, a DOH, Hinstrap, and Gentoo, are in order. The silly thing is, I've actually been using the bar plots incorrectly. There's no reason for me to talk about build lengths yet. Oh, it'll take a while to fix that. Let's go ahead and just look at the other types of graph while we're here. So say if we want a scatter plot, of numerical variables. Now, I'll fully admit, I do not have this stuff memorized. And I will literally Google something like Python, Seaborn, scatterplot to find some examples to refresh my memory of how we do these things. So the command turned out to be scatterplot. I'm going to put a numerical variable on the x-axis, a numerical variable on the y-axis. We're going to get a scatterplot there. To separate the groups, here we had 3 species of penguins. The parameter is called hue. So that way we could get that graph, and the nice thing is that the legend is automatically created. And there's something down here that I just wanted to try out real quick. Never mind. And then maybe for one more type of graph, we could make a box plot. Of a numerical variable across a categorical variable. And we have our information there. And that was actually going to be it for the examples that I had prepared. Do you all have any lingering questions about the material? Okay, for the sake of the video, just want to uh, thank you all for following along and getting a sense of what we may be able to do in the Python programming language. Admittedly, this was a quick and dirty introduction. There are many different avenues and skills that you may need in the coming months. So I welcome you to email and ask us about those when the time comes.